Hello everyone, this is Nikhil.
And this is Prabhanshu, and this is our electrical project, a piano note detector.
It samples the note played on a fourth octave on a keyboard, and after analyzing it displays which note was played on the LCD screen.
Now I will explain the circuitry. The main components include the KY038 sound sensor, the Arduino Uno, and an LCD screen. The KY038 captures sound from the environment by detecting pressure variations through its microphone, which are then converted into voltage signals. The signals are sent through the analog pin to the Arduino. The Arduino receives the signals and determines the musical note being played, such as from a piano. Once the note is identified, it is displayed on the LCD screen. This setup allows for real-time detection and display of musical notes based on surrounding audio input.
Now I am going to explain the method employed to determine the note played on the piano. First, the Arduino collects 128 samples using the sound sensor while applying the horn window function to reduce the spectral leakage. The collected samples are then processed to get average and RMS values to determine whether it is intense enough to perform the FFT. If so, the FFT is performed and the 5 most dominant frequencies are mapped to the respective musical ranges. These frequencies are then compared to the thresholds which are predetermined for each musical note range, and the one which is closest to its threshold is displayed on the LCD as the final keys. The code runs continuously in a loop to give real-time changes. Now we are going to show the demonstration of the model. First, the D major. Next, A. Next, the C sharp. Next, the G sharp. Finally, the B. Start.
Okay, so now I will be playing a continuous sequence which will be C, D, E, F, G, A, B. Okay.
Looking ahead, this project has potential for many exciting improvements. One possible upgrade is replacing the KY038 sensor with a more sensitive microphone module to increase accuracy. We can also integrate machine learning to recognize more complex chords and melodies. In future versions, the project can be extended to display note on a mobile app via Bluetooth or Wi-Fi. Adding real-time pitch tracking and visual feedback like piano key highlights could also make it a helpful learning tool for music students with better hardware and more advanced algorithms. This system could evolve into a low-cost digital tuner or music transcription device.
To conclude this project successfully, demonstrate how we can use Arduino, a basic sound sensor, and an LCD screen to detect and display musical notes. It showcases the practical use of signal processing with FFT and note mapping in real time. While simple in design, it lays the foundation for more advanced sound-based applications. Through this project, we learned about our audio signal capture, frequency analysis, and how to bring these concepts together into a working system. It's a great example of how electronics and programming can come together to create interactive educational tools.